Hey, good morning, everyone. I want to go through the first evidence question, the one that I posted yesterday. We'll be looking at making two different chemical equations. I'll be pointing out everything I was looking for in the process. Um, Please don't hesitate to let me know if you have any questions. So let's go ahead and begin. First one here. Sorry, one second. First one here. We have, when heated, solid baking soda, NaHCO3, decomposes into solid sodium carbonate, water vapor, and carbon dioxide. So let's just start figuring out the formulas for everything. We know the formula for this one's NaHCO3, so that's fine. Um, Sodium carbonate, that's a little bit different. When I go look on my little ion sheet, I see that sodium is Na plus and carbonate is CO3 2 minus. So if I have two minuses here, I'm going to need two pluses. Um, Water vapor is H2O, that one's easy, and carbon dioxide CO2. So let's put this all together. Solid baking soda, NaHCO3, which is a solid, is going to decompose into solid sodium carbonate. Remember, this is 1 plus. I have two minuses, so I need two of those NAs. Sodium carbonate. This is solid as well. Water vapor, H2O. This is a gas. Now, I've had some people turn this in without telling me the state of CO2. Ladies and gentlemen, you have a lot of experience with CO2. It's a gas. Yeah, it's a gas. There are some instances where you can make it solid, like dry ice, but that's you have to get really cold. That's not going to happen when we're heating baking soda here. All right, so let's go ahead and balance it. Hey, look, I see two sodiums. Well, the only way to get two sodiums is to have two of these guys. So two sodium hydrogen carbonates react to make two sodium carbonates, one H2O and one CO2. Counting everything, I see two sodiums, two sodiums. I see two hydrogens, two hydrogens. I see two carbons, I see two carbons. I see six oxygens, I see six oxygens. This is now balanced. All right, let's draw everything. So I'll go ahead and make my sodiums this nice pretty blue. I'm going to have two sodium carbonate, so there's two sodiums. Now here's two sodiums, but notice they're both attached to the same carbonate, so I'm going to draw them nice and close to each other. No sodiums there, no sodiums there. Next, let's go ahead and do the carbon. So this sodium is attached to a carbon, and this sodium is attached to a carbon. This two sodiums are both attached to the same carbon, and there's a carbon over here. All right, next, hydrogen. Here's a hydrogen, and here's a hydrogen. No hydrogens here, but two hydrogens here. And then finally, oxygen. Let's choose a nice, pretty green, I guess. Three oxygens in each of these. So three oxygens here, three oxygens here, three oxygens here, one oxygen here, and two oxygens here. Okay. So I want to really point out the important things to me. One, the drawings look like my equation. I have two sodium hydrogen carbonates. I have one sodium carbonate, one water, one CO2. It matches the balance perfectly. Don't worry about showing me the states in the equation, in the drawings, but I should at least see how it's balanced. Second, draw me things together that they're together, right? I had some students drawing me, well, okay, here's the sodium, and here's the carbon, and here's the oxygen, and they were drawing them all separate. That doesn't work for me. I need to see that they're all in the same group, that they're all put together into the same particle, into the same molecule. All right, one more. I'll do the one down below. I'm not going to go through and explain every step, but I'll show you what I was looking for. Hey guys, copper. You've seen copper before, right? It's a solid. As far as states go, I would expect you to know it says dissolved for silver nitrate, so you definitely got to know that's dissolved. Copper, it's copper, it's a solid. Silver, it's a solid. It even says it up here. And then copper nitrate, the copper 2 nitrate, it's an ionic compound, which means there's only really two options. It's either solid or aqueous. In this case, it'll be aqueous, but I would have accepted solid as well. But you have to give me something reasonable. Okay. 2 nitrates, so we're going to need 2 nitrates, which means I have 2 silvers, which means I need 2 silvers. All right. NO3 and oops, NO3 and O3. I guess if I was good at copy and paste, I could just copy and paste these. And oops, O3, silver, 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 silver. Notice those two are not attached to each other. And then copper. 1 second. Oh, let's not do that color. It's going to be way too close. Copper. Okay, just count everything up real fast. 1 copper on the left, 1 copper on the right, 2 silvers on the left, 2 silvers on the right, 6 oxygens on the left, 6 oxygens on the right, 2 nitrogens on the left, 2 nitrogens on the right. This is what I'm looking for. All right, maybe even put a big old arrow in the middle just so we know that that is turning into that. Should look just like your bingo chips. This is what I was looking for on this. Feel free to let me know if you have any questions. I'll be around. Stop by the Discord, send me a message on the Classroom. Yeah, if you had this, good job.